turn those type of equations, xy equations, into polar equations. And then, we're going to convert polar equations with the r's and the thetas into xy equations. Does that sentence make sense?
Yes.
Okay. So, believe it or not, almost all of the tools that you need to be able to go back and forth like that, you already have. Okay? And it is all based on this one picture which we love. And I'm gonna cry whenever I don't have to write this anymore because it's such a beautiful picture. This picture which we know so well, where you have a distance along the x-axis, a distance along the y-axis, maybe going up to this point here. What are we going to label the hypotenuse here? R, that's the radius, that's the distance. What am I going to label this angle coming up from the positive x-axis? Somebody else, but yes, okay, thank you. Theta. And then all of our equations which relate x and y to r and theta. So somebody tell me, how do I get x and y related to r? Someone other than Preston.
I don't know if this is right, but like r squared equals x squared plus y squared.
Yeah, it's the Pythagorean theorem. It's pretty much the right answer on everything in trig. Alright? So x squared plus y squared equals r squared. That's pretty good. What about x, y, and theta? Anybody remember how can I relate x and y and theta? Mari?
Tangent.
That's right. So I wrote tangent down. Now keep going. Tangent.
Y over x.
Okay, there is a y over x, but we're gonna say.
Tangent theta
Mm-hmm.
equals.
Mm-hmm. Y over x. X is there. Okay. What about going the other way around? I need to relate r and theta. Oh, let's just say to x. Anybody remember this? X equals. X does equal x, but I'm looking for something with r's and thetas. R cosine theta. This was the conclusion that we came to after, and you probably saw this in your previous class, where cosine theta is x over r, like the adjacent over the hypotenuse. But then you multiply both sides by r, and you get x equals r cosine theta. And then someone else, the y equivalent, y equals r sine theta. See, you already knew those four equations. They're so wonderful. They're so perfect. And that's all the theory that you need. Okay? What we're going to do is we're going to apply this in a slightly different way in order to convert these equations. Now, sometimes it's helpful to know why we want to do different things. We found out that there's some really neat formulas, some neat graphs that you can do in polar that you can't do with x's and y's, right? Well, it turns out you can do them with x's and y's, but it's kind of hard to get there. But if we can have the polar equation and convert it to the x's and y's, then we can mess with that. Or if we have some sort of complicated xy equation, we convert it to r's and thetas, then maybe for graphing purposes, then that'll help us out. I can tell you right now, if you plan on going into any more advanced mathematics, such as calculus, there are some things that you cannot do unless to a graph unless it is a function. And this is not a function, but if we convert this into r's and thetas, I'm pretty sure this one right here is in fact a function. Okay? And so things you can do with functions is something that's really kind of fun. It's called take the derivative of it, or find the derivative, or find the integral, and then that tells you all sorts of really important information about it. Now, what is that important information? You'll have to take calculus to find out. But it does play a role in finding surface area, finding volume, finding how fast something is changing, all sorts of very real applications, okay, not just math, all right? So anyway, this is pre-calculus. calculus, so that's why we're going through this. Converting from polar to rectangular. Go ahead and pass one. Alright, thank you. Take one, pass it down. Thank you. These, you might need to keep out your notes page because some of these take just a little bit extra space. So I don't know if you're gonna be able to fit everything inside this little region right here, so. Alright, so number one, we're gonna convert x squared plus y squared minus 7y equals 0. We're gonna convert that to polar form. So essentially, we're gonna look over there and see if there's any of those formulas that can help us out. We want to turn these into all r's and thetas. Does anybody see anything here that might be able to be converted into like an r squared or theta? Preston, you looking contemplative over there.
I think you can change maybe the x squared and y squared to r squared.
Combined together, yes you can, the sum. X squared plus y squared, we saw that earlier. I think Taylor told that to us, it's equal to r squared. So I'm going to just replace that with r squared. Minus 7. Now what is the y? What could we, Mariah, what is y equal? Yeah, r sine theta. So minus 7 r sine theta equals 0. So we're on the right track. However, they tell us that we need to solve the resulting equation for r. So we need to keep r all by itself. This is similar to a problem like, what if we had x squared minus 7 x equals 0. I'm going to kind of think of it like that. The sine theta always kind of throws everybody else off. I want to try to get this where the x is all by itself. If we're looking at this, this is basically an algebra 2 problem. Does anybody have any insights on how we could get the x all by itself? Naomi, any ideas? You see where we want to go, right? We'll get that x all by itself. Say again? Move every, well, if I do that, you see, maybe not everything, but because if I just switch all this over here, then all this becomes negative. But let's throw some of it over to the other side, such as the 7, okay? So that's not a bad idea. However, that 7 is being multiplied by x and b, right? What I could do maybe is I could add 7xb to both sides. So I end up with x squared equals 7xb. Is that kind of where you're coming from? So you can keep going or someone else can pick it up. Now how am I going to get that x all by itself? Take square root. Square root here, square root here. So I have x equals the square root of 7xb. And I just, b here is kind of playing the role of sine theta. Now there's a problem with this. I like it. I like the x all by itself. We do have it in terms of x equals, but I also have an x over here. You see where I'm coming from? And that's what's going to happen anytime that you have a quadratic expression, like we have here, or a quadratic equation, okay? This process of taking a variable and isolating it on one side is really good when you just have one variable and that's it. But if you have that variable and he's like got a squared term and a linear term right here, like an x squared and 7x, then this sort of process does not work. Okay? But we had to kind of go through that for us to remember that. Now, let's revisit going back to algebra 2. When I say quadratic equations here, there were other ways that you learned in algebra 2 about how to solve quadratic type stuff. Ferrari, you got a thought there? Or? Factoring, that's right. There actually were three ways: factoring, the quadratic formula, and graphing. Factoring is going to be the win for us. I notice there's an x here and x here. So we could factor out an x. So when I do that, what remains here in the first term is just a regular old x. And then I would say minus 7b equals 0. The benefit of factoring is now I can take this principle, okay? Trey, remind me, if I have any number, let's say a times 0, what is that going to give me? 0. Okay, so remember that anything times 0 is 0. So here, class, if I have two things that are multiplied together and they equal 0, then what can I logically deduce? I have two things that multiply together to equal 0. Then what does that tell me? Go ahead, Sarah. Not quite. Not that they cancel, because is there any other way, Trey, that I can get 0 when I'm multiplying things? And I'm multiplying a times b. Like what about 5 and 1 over 5? Well, 5 times 1 over 5 is just going to be 1, right? So it's not like it's not like they're reciprocals. And 5 times negative 5 is negative 25. So does anybody know any way that you can get 0 when you're multiplying? Multiply by 0. Yeah, one of those suckers has to be 0. Either this is 0 or this is 0. That's the only way. So when I tell you I have two things, an x and an x minus 7b, that are being multiplied together, and they equal 0, then I can conclude that either this is 0 or that is 0. Let me say that again. If I have two things that are multiplied together to equal 0, then I absolutely know that either the first thing is 0 or the second thing is 0. I'm pretty sure that you discussed this last year in Algebra 2, but it's been a little while, and maybe you didn't make that connection. But that's why it is. Naomi, does that make sense to you? Yes. Good answer. Is it really though?
Kind of, yeah.
Okay. It's sort of like, well, there's an old joke. It's actually kind of a riddle. And it kind of is almost true. I've got 2 coins in my pocket, actually, though. But I've got 2 coins in my pocket, and they add up to equal 35 cents. All right? But one of them is not a dime. What's the other one? Or what are the coins? I've got 2 coins in my pocket, and they add up to equal 35 cents. One of them is not a dime. So what are the dimes? Well, what are the coins? Quarter nickel would be 30 cents. I'm telling you, I've got 35 cents. I think the actual joke is 30 cents. But anyway, I just modified 35 cents. And I've got 2 coins. But one of them's not a dime. So what are the coins? They're American coins. Preston? Ferrari? Lonnie? Do you know what the coins are?
I don't think that's possible.
Don't think it's possible? It is possible. 2 coins in my pocket, add up to 35, one of them is not a dime. Screen sword?
2 coins are the same.
They're not the same.
It's a hybrid.
No, it's not. The coins happen to be a quarter and a dime.
So one of them is not a dime.
I said one of them is not a dime.
Oh, my goodness.
That one's not the dime. Okay? The other one's the dime. Okay? So, I've got 2 things that multiply to equal 0. Either this one is 0, or that one is 0. Does that make a little more sense now?
Mhm.
I don't know if the riddle helped. But anyway, So we would say either x is 0, in which case 0 times this equals 0, or that is equal to 0, because then we'd have 0 times the other thing would be 0. So either x equals 0 or x minus 7b equals 0, and I can solve this using our friendly linear term, add 7b to both sides, and I have x equals 7b. So I'd have x equals 0 or x equals 7b. Everyone good? Okay, that was the side problem using b instead of sine theta. Let's go back over here to this, and I notice I'm trying to solve for r. I have an r here and an r here, so I'll factor out an r. So what's left here in the parentheses is r minus 7 sine theta. Now, Sarah, I have two things that are multiplied together. This is the first thing. This is the second thing. When they multiply together, they equal 0. What can we conclude? That's right, one of them is 0. Or both of them, both of them. So either r equals 0, or, anybody? Okay, you mean r minus 7 sine theta. The r equals 0 comes from this part right here. Yeah, or this whole thing right here, r minus 7 sine theta is 0. And what we can do is we can add 7 sine theta to both sides, so we have r equals, oh, are we recording, Mr. Greatsword?
Yes,
Okay, I appreciate it, thank you. Man, I did not want to do all that stuff until next year. So r equals 7 sine theta. So now we have two variations, alright, of two equations. We have either r equals 0 and r equals 7 sine theta. Now, does anybody remember, based on our knowledge of graphing, what does r equals 0 look like? What would a graph look like where the radius was 0? Radius 0. Like right there, right? Just a dot, okay? That's not the right answer, okay? This is something with x's and y's and things are moving around or like that, okay? R equals 0 is not the answer because that's not what it is. So I can't give you a better answer than that. Mathematically, it is a possible answer, but what they're looking for is the equation that's going to generate this graph. Anyway, so r equals 7 sine theta is the official right answer on that one. I mean, I can tell you from the fact that I know what this is. This is a circle that is up, you know, if we were to graph that, you could use Desmos to graph it, and it would look like this. And this is the same thing. That's a graph that looks like that. So you test it. You can test it. This mathematically, r equals 0 will give you the same value, but it's not going to give you the same graph. Okay. That's probably one of the longest ones. Let's go ahead and do some easy ones now. Number 2. Let's convert that equation. Screen sort of think we're going to need to have.
yeah.
Taylor, call it out to me if you don't mind.
5x minus 2y plus 2 equals 0.
5x minus 2y plus 2. Alright, so let's go ahead and substitute things in step by step. So I'm going to replace the x with r cosine theta. So 5 r cosine theta minus 2, replace the y with r sine theta. The plus 2, I'll just leave that as is. get the r all by itself. So first thing I might do is I might subtract 2 from both sides. So I have 5r cosine theta minus 2r sine theta equals -2. Anybody have an idea on how to get the r all by itself at this point? We got Preston. Ferrari had a good suggestion last time, which is also a good suggestion here. Factor is what I was looking for. Notice we have an r term here and an r term here, so we'll just factor that out. So I'll say r. What's left in this one is 5 cosine theta. What's left in this one is 2 sine theta. Now that little game that we played where you had a times b equals 0, and so then either a equals 0 or b equals 0, that game only works with 0, okay? Because the fact of 0 is, it's a property of 0 that when you have two things that multiply, and one of them, and it equals 0, one of them has to equal 0, or the other one has to equal 0. If I have two things that multiply and equal -2, well, those numbers could be 1 and -2, or it could be like 4 and -1/2, or it could be like 10 and -1/5. I mean, there's lots of different combinations, an infinite number of combinations of things that I can multiply together to equal -2. So in this case, that doesn't even really bother us because I have r right in here. I don't have any r's in here, so literally I can just divide this whole side by 5 cosine theta minus 2 sine theta, and divide this whole side by 5 cosine theta minus 2 sine theta. Anything divided by itself reduces to 1. And I get the formula r equals -2 over 5 cosine theta minus 2 sine theta. What a strange equation. But the right one. Anyone have a question? Present? All right. That takes care of number 2. Let's look at number 3. Number 3 seems to have 2 parts. Part A. So it says convert each polar equation to rectangular form. Okay, so now we're going the other way. Now we have a polar graph. Theta equals 4 pi over 3. Let's kind of think about this for a second. What did that graph look like? Does anybody remember when we had, yesterday or 2 days ago, I guess, when we were graphing, and we said theta is 4 pi over 3. What did that graph look like? Does anybody remember? It was a line, because the idea was it doesn't matter what r is, whether r is 0 or 1 or 2 or 3 or 4 or -1. It's theta is always 4 pi over 3. Now where is the 4 pi over 3? You might need to pull out that trick chart. Where's the 4 pi over 3 line?
The third quadrant.
Third quadrant. I think it's the first tick down, isn't it?
No, it's the last one.
All the way down here?
Mm.
So it's the 60-degree Rayleigh angle? Alright. So each one of these would represent, you know, a radius of like 0.1, 0.2, 0.3, 0.4, 0.4, 5, 0.6, all you know, and then negative, and so on and so forth. So that's what the graph would look like. Does anybody know the type of graph that would, in terms of if we had y equals? Like, well, it's gonna be, this marker is really nice. The equation for this would be like y equals some number times x. It's a direct relationship, direct proportion, so it's proportional, and it goes through the origin, so it's sort of like y equals mx. I guess we could maybe put that instead of a number sign. Y equals mx. There's no plus b because there's no y-intercept. It goes, well, there is a y-intercept, it's northern, so plus 0. So our answer should look like that. It should look like y equals mx. Alright, so that's just sort of preliminary things to think about. Theta equals 4 pi over 3. I'm going to try to turn something with thetas into y's and x. And this part right here, tangent theta equals y over x, is my best option. So what I'm going to do, something pretty strange, I'm going to take the tangent of both sides of the equation. Now, based on our formulas over there, tangent of theta is equal to y over x. The tangent of 4 pi over 3, if you remember, the way that we found this on the unit circle is we go to that 4 pi over 3 line and we write the y value on the unit circle divided by the x value on the unit circle. It's been a while since we did that, but y'all remember how to do that? To find the tangent of 4 pi over 3, you go to the unit circle, find 4 pi over 3, and tell me what is the y value over the x value. So class, Sarah, tell me what's the y value there at 4 pi over 3? Negative root 3 over 2. Nayeli, x value? Negative 1/2. Alright. So we've got fractions of fractions. I really don't like that. Now there's negatives, those will cancel each other out. But the way that we deal with fractions of fractions, if you remember, is you will write the numerator. Root 3 over 2, have those negatives cancel each other out. And then times, flip it, the reciprocal of the denominator, so times 2 over 1. That's nice because those cancel. So we just have y over x equals root 3. What they're looking for is y as it depends on x. So I'm going to multiply both sides by x, and I have y equals square root of 3 times x. Preston, does that fit our expectation? It does. It's a proportional equation. So we're done with part A. There you go. Part B, r cosine theta equals negative 4. Do we see anything for r cosine theta on that left-hand side? Trey, what do you see? Yep. It's x. data? Yes. This is the polar equation. This is the rectangular equation. That was nice. I'm gonna give you about a minute. See what you can do with number 4.
Would we have to put in the linear formula, the, number 3B?
The one that I just finished in box.
Yeah.
You cannot get, there's no y's at all. So you can't turn this into a y equals mx plus b. It's, if you remember the graph of x equals -4 is literally, it's just a vertical line, it's not, y has no part of it. So that's good enough. Vertical lines. So as a table, see what you can do with number 4a or 4b or both. I'll give you about a minute and a half, ready, go. Now 4A is kind of tricky because we haven't done one like that. So if you want to skip to 4B, I'll take that. Alright, oh, 2 minutes, we gotta get going. So, anybody do anything with 4B? From theta equals 1 pi over 6, what'd y'all do?
Set it equal to 10 theta.
Alright, so take change to both sides. Tan theta equals tan 11 pi over 6. Keep going.
Yes, and then it's gonna be -1/2 over square root of 3 over 2.
Positive or negative?
Positive.
Class, we agree on that? Take 1/2 and root 3 over 2. And left hand side, that's gonna be your y over x. So y over x equals
Negative square root of 3.
You get something like that. Those twos cancel, and we have y over x equals negative. And that's not what you said. Did you rationalize the denominator? Alright, everybody else do that? So multiply that by root 3 over root 3. So y over x equals negative part A. So we've got R equals 6. Anybody have any recommendations on how to process that? Okay, yep, we wanna, yes, totally agree. We wanna square it, okay, so we do want an R squared here. You've got two ways of doing that. You can either square both sides, or you can multiply both sides by R. I recommend square both sides. So do left side squared equals right side squared, so that it just becomes R squared equals 36. Then do our substitution. X squared plus Y squared equals 36. And on these problems, Alex will accept X's and Y's on the same side when they're squared like that. So good for us. That is a good answer. Just like Y equals negative root 3 over 3, X is a good answer over there. Alright, one more problem type and that'll begin class. So number 5, that one kind of looks like that other one that we did, doesn't it? Kind of with the R equals and this crazy fraction here. Yeah, it literally, we're just gonna kind of work our way backwards and end up with those X's and Y's. So part A, R equals 6 over negative 9 cosine theta plus 7 sine theta. What I'm going to do is I'm going to multiply both sides by that denominator, by the negative 9 cosine theta plus 7 sine theta. So that I have R times negative 9 cosine theta plus 7 sine theta equals 6. You can kind of see this is literally just the reverse of all those other processes. Then I'm going to distribute that R, so I have negative 9 R cosine theta plus 7 R sine theta equals 6. Looking at our key formulas, class, what is R cosine theta? X, so we have negative 9x plus 7. Class, what was R sine theta? It was Y, so 7y equals 6. I'll look and see if Alex accepted that, or if they would, if they want the set it equal to 0. I'm not sure where that original one is, but oh, here it is. Yep, I did that back here. Equals 6 is fine. We don't have to set it equal to 0. Good for us. All right, part B. R equals 4 sine theta. You're gonna love this one. I'm gonna take on this one both sides and multiply it by R. So I'm taking the left-hand side, multiplying it by R, taking the right-hand side, multiplying it by R. So that on the left side we get R squared, and the right-hand side we get 4R sine theta. I do that because R squared, as we saw earlier, is equal to X squared plus Y squared. And the 4R sine theta can just be simplified to 4Y. And I think Alex will also accept that as well. X squared plus Y squared equals 4Y. Good deal. Alright. So, class today we talked about how to convert from polar equations into rectangular, how to convert from rectangular to polar. Couple different techniques, sometimes squaring both sides, sometimes multiplying both sides by r, sometimes multiplying, taking the tangent of both sides. But in the end, all different tricks and utilizing those substitution values, okay? This particular homework assignment will begin next Friday. It's on the online system, which I'll get an account for you. Probably get you set up on Monday for that. Alright? Hope you have a good weekend. And the polar season is almost over.